Yeah. So we're live now. Good evening to those persons who are watching us live on YouTube. If you're there, thank you for joining us. And of course, you know you can participate by giving your responses in the chat. And of course, we'll be going live this week, throughout the week. I'll be going live through this week and ensure that you are ready to go. So we'll be continuing to work on our paper 2 questions that we were looking at the last time we went live. And of course, we'll be starting now. So um, let the games begin. So let the games begin, right? All right. So once you're on our YouTube channel, I just want to ask that you acknowledge yourself, you identify yourself so you can be acknowledged as well. All right. And of course, I'm your host, Ronnie Bernard, and I'll be taking you through the maths class for today. All right. And of course, we have our students on Zoom as well. All right. So let us get this thing up and running. All right. And of course, I'm your host. All right. So let us go for our board to share our first question. Now, my style of teaching students is I like when my students think things out. So let's see how best we can, get this thing up and running. All right, can somebody read question 5E for please quickly? Are you seeing the question? Can somebody read question 5A for me, please? Anybody? Nobody? Nobody? Is everybody hearing me, by the way? Anyone hearing me? Hello, is anyone hearing me? Is anyone hearing me? Is anyone hearing me? Anyone hearing me? So why nobody not answering? Yeah, but unmute your mic and answer so I can know. I mean, unmute your mic. I'm gonna always see that the chat is there. All right, so just unmute your mic now, please, so you can respond to me as well. All right. All right.
Okay.
Okay. All right. No problem. All right. I was hoping that somebody could read question 5A for me, but if you're having problems with your mics, then no problem. I will just read it. I'm going to discuss it as we go along. All right. All right. So let us. I'm trying to share the link with my sixth formers first. Let's go. All right. So it says the diagram below not drawn to scale. Now, when you see them say not drawn to scale, I normally advise my students to draw it to scale so that you can get the accurate measurements, right? Draw it to scale so you can get the accurate measurements. Now, it says it shows two straight lines. JK, now you take a look from J to K. Then from J to L, good, intersecting a pair of parallel lines. E to F, G to H. All right. Now, as I've always said to you guys before, get yourselves familiar or acquainted with the diagrams that they have there. So before we go any further, if you come up on questions like these, your geometry set is your best friend. So you draw it real, especially you draw whatever angle they give you, you make sure you draw that angle as well. All right. Now, so let's look at this. Can anybody identify the shapes? Can you look at the diagram and see if we can identify the shapes? Let me know, please. If we can identify any shapes, they can identify there.
Triangle, sir.
Triangle, very good. How many triangles do you see, Kimura?
One.
One. Okay. All right. So it's Kimura. This is one triangle. Okay.
Two.
Jamir says he saw us two. All right. Kimura says she saw two. So I saw a big triangle. I saw a two too. And a small triangle. Right? Big huge triangle. And a small one. All right. Now, there's something about and Tracy just sees two triangles. All right, good. There's something, and if anybody's on YouTube, of course, I say you can respond to my questions, and of course, you will be so acknowledged. All right, good. And the persons who are on YouTube, if you're not seeing my image big enough, all you have to do is simple go full screen on your device or pinch your device and stretch it like a picture, and of course you'll see it full screen. All right, so let us proceed same way. All right, and those who are on YouTube, you may share the link with a friend or family, and if you have not yet subscribed, hit the subscribe button and subscribe, of course. All right, now if you were to draw just normal lines, let's draw two normal lines. Let me use this instead. I'm going to draw a shape different from that shape. All right, so what shape, can anybody identify the shape that I drew a while ago? Can anybody identify that shape? Can anyone identify that shape that I just drew a while ago?
Triangle.
Look good, Kimola, look good. Look good. Huh? What is that shape?
That's opposite.
Okay, I think right. That Kimura, Kimola, that could never be what you call it. Honestly, couldn't be what you call it, right? That's a square. Now, does anybody know what each corner, if you want to call it corner, right here? Can anybody tell what angles will be right here? And the angles will be right here. And the angles right here. Huh? All right, so Ramiro said 90 degrees. 90 degrees, right? You are very much correct. Now, if I want you to observe now, and just 90 degrees. So if we have 90 degrees right here, and 90 degrees right here, if I were to add the two angles right here, how much would it be?
180.
How much?
180.
180 degrees. Very good. So do you notice then? Do you notice then that this line going up and this line going up, they're also parallel? You notice that too? You notice that? They are parallel.
Sir.
And the angle right here.
Yes, sir.
And the angle right there also 90 degrees. And they are also parallel. 90 plus 90, 180. They're equal, yes. Now, does anybody have a geometry set by any chance at home? You have a geometry set Kimura, you have a geometry set Lexi?
Yes, sir.
Well, I don't know if Lexi can demonstrate for us tonight because we have internet issues. Kimura, what say you? You have a geometry set, Kimura?
No, sir.
What do you mean on a geometry set? Hello, everybody's supposed to have a geometry set, you know? Everybody's supposed to have a geometry set. You better get one by tomorrow, by Tuesday. All right. All right. Does anybody have a protractor at home? Ruler, pencil? Anybody? Nobody?
Whatever pencil.
No, you wouldn't need that. All right. What I wanted to do is to run the investigation. It's to run the investigation and draw any quadrilateral, because a four-sided figure is also known as a quadrilateral. Tracy, right now, we're going to need a protractor to do the measurement. Everybody need to get their instrument, right? You need to get the instrument. Very important, the instruments, all right? Okay. Now, but please note that every quadrilateral, the total angle in a quadrilateral is 360 degrees. And also note that the angles that are between two parallel lines, the sum of the interior angle between two parallel is always going to be 180 degrees. But I didn't just want to tell you that. I wanted you to prove it to yourselves by using your own geometry set. But hopefully that you'll prove it to yourselves shortly. All right. So good night again to those persons who are visiting us on our YouTube channel. I am Mr. Bernard, of course, Ronit Bernard, and I will be able to, I want to acknowledge you, so please state your name, where you're from, and of course you can participate in the class as well. Good. All right. So let us continue from here. So the angle y and x are two angles formed between two parallel lines, as you can see, just like this figure up here. So please note that y and x, when you add up y and x, it must equal to 180 degrees. So we're to find the value of w, x, y, and x. Now, there's something you need to know as well. We can pick up a principle right here. Angles form on a straight line. Anybody know about angles form on a straight line? What do they say about angles form on a straight line? Anybody knows? Anybody know what do they say about angles form on a straight line?
So they're equal to 180 degrees.
Equal to 180, exactly. So the angle form here and the angle form here, when added, must be equal to 180 degrees. And you can use your geometry set and prove those theory correct. All right. Now, we are given an angle right here, 128 degrees, but we are given an unknown angle right here, which is what? Angle X. So if you want to find out what angle X is, I don't want Kimura to answer. I want somebody else to answer. If it is that the principle says that angles on a straight line, the sum of the angles formed on a straight line is equal to 180 degrees, and you are given an angle of 128 degrees right here, then what would you do to find the angle of X? All right, that's a Tracy suggesting that we subtract 128 from 180 degrees, and that's correct. Very good, Tracy. So what then will be the answer for that? 128 from 180. What's the answer for that? Anybody? So therefore, the 52 degrees. So therefore, the angle x is equal to 52 degrees. 52 degrees. And this you must give reason. Now, when you're given the reason now, when you're given the reason for the answer, you're basically restating the principle, right? X, the angle x, so you simply stated that angles form on a straight line, and let's move this, on a straight line, are the sum then, the sum of the angles, the sum of the interior, the sum of the angles formed on a straight line is equal to 180 degrees. Simple. Let's restate the principle. All right? So that's all you have to do when you're given the reason. So you have to know the principle. All right? Good. Okay, I got your message, Nastasia. So of course it's streaming live now, so shouldn't have an issue, right? Good. So some of the angles formed on a straight line is that. Now they of course they are gonna ask you to find the remaining angles y and x. Now, so the next question then is so now that we find angle x, we can now find angle y because we based on the illustration at the top right here, you'd have noticed that angle y and angle x is formed between two parallel lines, and the sum of the interior angles formed between two parallel lines is also equal to 180 degrees. So if angle x then is 52 degrees, then what is angle y? No. Couldn't be.
There, 128.
128 degrees. Couldn't be Ramirez. So if this is 52 and y and x is equal to 180, they have to take 52 from 180 and you get about the same 28 degrees. That's correct, Kimura. So y, so we find these two now. So they've gone some more marks. And the reason again is that they are now between two parallel lines, and therefore the sum of the interior angles formed between two parallel lines is 180 degrees. Now, the angle y. The angle y. Now, if you are smart, and I know you're smart, you could easily find the angle to the corner. So for some students, they use their little brain and they will try to figure out the angle right here. Knowing the angle for y and the angle for x, they can find the angle right here. Because what is being formed right here is a quadrilateral. And then the angle, when you add up everything together, you get an angle of what? 360 degrees. So I'm just showing you what and what you can do. It is possible, right? So, but you have to get this, you have to have the geometry set. This class is best start when you have your geometry set. So you can be busy doing your investigations as well. It is very important that you have a geometry set for the class going forward. Okay. Now, so let us continue. Now, so let us find the value of this angle right here, even though you were not asked to find it, but you can still find it to help you find the angle for W. So let's go. So we have 28 right here, 52 rather. We have 52 right there. 52 is right here. and this is 128 right here, and it's 100. So out of all of this, the 100, the 128, the 52, and then subtract it from the 360 and tell me what angle we have formed right here.
Say again. Repeat that.
I see 135. Everybody get 135? What 135? What not answering me, boy? Tell him. I saw Anastasia at 125. What is 135? Tell me. Ramirez got 80.
I wasn't hearing.
Now I'm saying you want to find the angle right here. Add up the 100, the 128, and the 52. So 280. So it's supposed to be. So
80,
we have
sir.
80. Okay, so two persons got 80. So let's check it. We double check. 100 plus 180 is 280, and you minus that from 360, so the answer is 80. Anastasia, you need to do the maths different. So minus that from 360, and our answer is 80. So whoever got 80, that's correct. Now, if you add 80 to 52, how much you're going? Now we have a complete triangle form right here now. We can now find this angle up at the top right here. Good. You can now find an angle at W by using the principle that the sum of the interior angles in a triangle all adds up to 180. So if we have 80 here plus 52, how much is that going to come to? 80 plus 52. That's 132. That's correct, Ramirez. So if we subtract 132 now from 80, how much are we going to get? From 180, that is, sir. We're going to get what? We're going to get 48 degrees. So the angle right here is 48 degrees. All right? 48 degrees.
Sir, can go over that, please.
All right, let's go back over that again. Now, what I said before, we found y and we found x. But we want to find w. But just in case you don't remember a particular principle, then you could notice now that what we have right here, let me use my little spotlight. What we have here, from here to here, to here, to here, to here, is a four-sided figure, which is called a quadrilateral. And the sum of the interior angles in a quadrilateral is 360 degrees. So if you have three of those angles out of the four, you add up the four of them, and you end up getting a certain amount. They 280, a matter of fact. When you subtract 280 from 360, you will end up with what? 80 degrees. So we found this angle right here, but this angle W and this angle X and this angle here is a part of the same triangle. And we know that the sum of the interior angles, you hear me clearly so far now, Kimura?
Yes, sir.
So those three angles are the same, are part of the same triangles now. Same triangles. So when you add those, when you add up these two and subtract it from 180, we end up with 48 degrees. Clear now?
Yes, sir.
Right. Now, I'd rather though that we use geometry set in the class, because for me, I am teaching like this for the sake of those who are on YouTube and time. But when you get the videos to watch, the worksheets to do, in the videos, students, you don't watch it like a movie. You pause the video. You follow the instructions in the video. If I do something, you follow what I do. Make your own things. Like when you're doing the measurements, you saw me making solids. You make solids too. Because it is by participation and by doing you will learn mathematics. At least benchmark. And then when you come to class now, you're going to transfer that learning while you're in class, either doing another worksheet or participating in a discussion while we're going through a past question. That is what the program is designed for, flipping the classroom. Not for you to come to class and learn something for the first time. No, no, no. You learn for the first time by watching those videos that you get. So I'm going to be releasing the videos to you for the next topic that we're coming up to now. The next question that is, I'm going to release the videos to you. You're going to watch those videos in preparation for our next class. So let us move on to our other slide. So we have covered these two already, right? All right. So we're going to be looking at this question now. And this is part B to number 5. Now, here I have a graph. And I want you to look at both triangles and tell me what you observe about these two triangles. Just use your eyes and tell me what you observe about these two triangles. What do you observe about it?
They're right angle triangles.
Yes, they are right angle triangles. Anything else?
And I think
Go ahead, I'm listening. They are both right angle triangles.
the what the I don't remember what thing that reflection of
Oh, so okay.
RSC.
Well, Tracy said that they're reflecting. Okay. Well, they're reflecting, yes. But request I did say that, but I ask you to tell me what you see with your eyes. So they're right angle triangles, and what else? They're the same size. Aren't they the same size? Aren't they the same size? That's what I expect to say. They're the same size. All right. So they're the same size indeed. Good. All right. So let us continue from here. All right. Now it says triangle RST is reflected in the line x equals 6. Now you want to know what the line x equals 6 is, or where that is rather. Now the line x equals 6 is right here. Let me show it. The line x equals 6. So you have to look for the number x, number 6 on its x-axis. And this is the line x equals 6. Hold on here. Yeah. Line x equals 6. Oh, sorry. I went to that part is not ready to come up yet because sorry about that. I suppose to start at part I, which is right here. Sorry about that. All right. Part I, this is part I, the first part of the question, and this part is part 2. Now, to describe fully the transformation which maps RST, which is this one right here, to RST, the image of RST, which is this. Now, you have to describe it fully. There are, this question is based, as you can see, is based on transformation, right? Transformation geometry, to be precise. And there are different forms of transformations. You have reflection, you have rotation. I see where Lexi is saying glide reflection. Okay, all right. So do you want to expound on what glide reflection is? What do you mean by glide reflection? All right. So a reflection obviously exists right there, and something else. So let me list again the type of transformations that we have. So we have translation, we have rotation, we have reflection, and we have enlargement. Good. All right, so Lexi said that we have translation and reflection. That's correct. Those two are there. But this question is which one exists first and when the other one came afterwards. Now, this is the image. And if you recognize that RT and RT is also here. But let us say, I'm going to draw back RT right here. And let us see if it's indeed a reflection or not. Let us see. So I'm going to draw it back right here. So if it was a reflection, like that, and then we go 3 up, and then we come here. Now that flexi doesn't look like a reflection of such. Nope. Doesn't look like a reflection. Because
Then why cross over the x-axis then?
come again, why do what?
Why did it cross over the
The x-axis.
x-axis?
Then you are saying to me then on the y-axis.
So I'm gonna ask
But-
why it come over the other side then.
Oh, well, good question. It could be.
But if it was a reflection, wouldn't T be where 2 negative 1 is?
Exactly. So it could not be a reflection right there. Very good. So it's obviously not a reflection. So you say why these type of questions are very tricky. And you have to, and that's why I rather to have a drama set so I can make you discover things on your own and manipulate the type of questions that are here. Using a drama set will make life easier. So what I did now to prove it's not a reflection, I just draw it right there. However, we can prove though that it is a translation. It is a translation. So for a translation to take place, let me see if I can draw a triangle that I can actually move. I just want to see if I can move this. I'm not sure I can move it. Okay. All right. Perfect. So I have a plan. I have a plan in mind. Yeah? Lexi. So I'll go on Lexi. I have a plan in mind. So I'm going to redraw this. look like that. All right, so there we are. We're gonna move this along. Come on, move it. All right, so I'm gonna be moving this triangle. Good. Now watch this now. You got to watch and watch carefully. If you don't watch carefully, you're gonna have a big problem. I give it the color. So we give color. All right. So say we're there now. Oh, look. Looking good? We're looking good, Lexi? So let's go. So we're gonna move it.
Yes.
We're gonna move it and go where R is. So we see where R is, right? So that is two places to the what? To the what direction? To the what? To the what? Right? To the right? To the right. Then I'm gonna come down. I'm gonna come down to meet this one. So we're gonna come down now. 1, 2, 3. So it means then that the triangle was moved 2 places to the what? Right, and 3 places down. 1, 2, 3. And another way you could move that, they could do it, is, and that is why I made a video that looks similar to what I'm doing, where you have to cut out that piece and use it. So I think I'm going to send that. That would have been the set of lessons that you'd have gone to when you finish your measurement lessons. This is what you'd have gone to next. But we got to move on, right? All right. So let's look at it a different way. They will come back to this. They show a different method they can use. Watch me now. So we're going to move the point R. Ready? So 1, 2, right? Everybody see that? So from here to here is 1, then 2. So we'll come down now. 1, 2, 3, 4. Everybody saw that? Everybody saw that? Everybody saw that? Good. All right. So we move the R 1, 2, then come down 1, 2, 3, 4. So that it's a vector actually. So we have +2, -4. Now if all the points follow the same vector, then you know it's a translation. Let's try S now. So note where S is right here. So we're going 1, 2 again, then 1, 2, 3, 4. So that is, so it's the same 2, -4. So the same translation vector taking place right there. So let's follow. Let's watch the T now. So come again from here to here. 1, then 2, then 1, 2, 3, 4. So it is indeed a translation. So the transformation, so when you're writing the answer to the question, then you write it like this. So the transformation which maps RST to R S dot T dot is a translation using vector. You put a vector, you write a vector to negative, sorry, not -2, but not negative 2, but positive 2. Wow, mistake again. And negative 4. Negative 4, right? And that's it for that part of the question. So it might look like a reflection, but you have to know that with a reflection, that this side would have turned and faced this side. Everybody see that? Good. So it might look, the eyes can trick you. Don't make your eyes trick you. You have to do the test to ensure that what you are assuming is correct. All right. That's why I'm going to give you those videos to watch. And make sure you watch them in the people. Get a graph paper and watch them. It makes sense to watch without having the graph papers. The graph paper and watch them. All right. Yes, I didn't tell you. All right, so let's move on now to the other part. And note that, as I said before, you can always go back to the YouTube channel and look for the video. You rewatch it if you didn't get everything from what I just said. All right. Now, there's a triangle ST now is reflected in the line x equals 6. On the graph above, draw a triangle, the other image, right? Okay. Now, so they are saying to you now that on the graph, so they want you now to reflect this same triangle now, but this time we're going to use in the line x equals 6. So you have to know what we mean by the line x equals 6. The line x equals 6, you look for the number 6 on the x-axis. If there's a line y equals 6, you look for the number 6 on the y-axis. Is that clear? Is that clear?
Yes, sir.
Okay.
Yes.
Then we're going to go. So we're going to draw the line y equals 6 right here. And they want to reflect this now over this side. So what is it going to look like now? So this, so S is 1 unit away from it. So therefore S is going to be 1 unit away. Then now R is going to be 3 down from S. Good. Then we're going to 2 down right here. Good. And then you're going to connect them. There you go. So it has been reflected in the line y equal 6. The Bible says, sir, how you get that? How you know that? How you come up with that? Now, if you look in the mirror, I want you to tell me now, when you look in the mirror, are you equal distance from the mirror line? Is your image in the mirror the same distance away from the mirror?
Yes, sir.
Good. So that is it. So this is like a mirror line. This is you in the mirror. So if you're at S, then you must be 1 unit away from the mirror line. And naturally, if you're at R, must be 1 unit away from the same amount of unit that the R is from the mirror line, must be the same amount of unit. The image of R is from the mirror line. And the same goes for T. Then you get your reflection. So reflection in the line y equals x line in the y-axis and x-axis is not difficult. Now the y equal x or whatever y equal to or x equal is not difficult. The difficult ones really is when you have to find the matrix for it. Or use the matrix to do the reflection. And that there are some things you have to recall. But as I say, when you watch those videos that will be released here this evening, tonight to tomorrow, all right, ensure that you have your graph papers, you have your pencils, you have your scissors, you have your ruler, so that the watching the videos can be meaningful. You get the bulk of my teaching through those videos. Them long, yes, because when you watch it in a one, and so that is why we charge, we We are giving away our service, and trust me. Well, I am giving away my service because when you watch those full videos, it's like a class in its own self. I don't know if you agree with me, but if you be honest, it's a class in its own self. That's why it's allowed. So therefore, when you watch the videos, treat it like a class. Pause, make your notes, follow the instructions given by the narrator, who is me in that case. Or for any video you watch, any tutorials you watch, the teacher give instruction, you follow instruction. All right. Good. So we have followed that instruction given in the question itself, right? So you say before the instruction in the question too. So on the graph above, draw a triangle RST, which you did that. The image after answer after the reflection. Now them say now write down the coordinates of R. So the coordinate of R in this case here will be, so R would be right here. So that would be, I think 9 is here, so it will be 10 on the x-axis and 3 on the y-axis. So they're just testing to see if you know how to read the coordinates. 10 comma on the x-axis and 3 on the y-axis. All right. No, that would not be correct from yours. No. Not correct at all. Remember, so R is right here. R is right here. So if you're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10. Line it up. And then 3 on the y-axis. Right there. So it's nice try though. They should it's not negative 10, it's positive 10. Positive 10 because 0 is on this side, you know? So everything after the 0 coming in that direction is positive. In the opposite direction is negative. So it's positive 10, positive 3. 1 mark. All right. So that is that for that question itself. So with that, we're going to pause here now. There are some questions in your workbook that you need to do. All right. But I'll be ending the stream right here. But before we end the stream, we just want to say thanks to those persons who joined us for this short session tonight on our YouTube channel. We'll be streaming live through the rest of the week. So please, if you have not yet subscribed to the channel so that you can know exactly when to tune in to CDP Library Services for maths classes. If you're watching on YouTube, I'd advise you to have your pack of graph leaves, have your geometry set, and your calculator, a pencil, a pair of scissors, and some blank paper. So you can participate in the interactive part of the class and learn as we go along. So tonight, we say thanks again for those persons who have joined us on YouTube. And students in Zoom, please stay on. Brief but important discussion, and they will take it from there. So I got one person that said we could run the class through the week. So I'll be streaming live through the week. So for persons who are not able to make it for the classes, you'll see it live on YouTube as well. All right. Okay. So let me just close the end the live